Today we are going to now be starting from basics of conditional probability. I'd like to remind you to subscribe, clicking on the subscribe button below this video if you've not subscribed. If you have any challenges in mathematics topics, just let me know by leaving a comment for me. Now, we are now going to start with basics of conditional probability, and this is the first of the actual main probability class that we are going to be having. This is the first one. Now, what are the prerequisites? I assume that you have some basic knowledge of probability that something will occur given certain event. For instance, I've left this page open because this is my site where I also put in the procedures for you in case you miss out something. I assume you have a basic knowledge of probability. For example, if there are 3 red balls and 2 blue balls in a bag, someone picks a ball at random. What is the probability that it is a red ball? There are 3 red balls, 2 blue balls, total of how many? Of 5. So it means that probability that it is a red ball is 3 over 5. Probability that it is a blue ball, it is 2 over 5. Or what is the probability of getting a 3 in a fair 6-sided die when it is rolled? I'm sure you also know it. In 6 sides, is only have to be one side that is going to show up, and that is 1 over 6. So these are basics of probability that I think you should know by now. I'm not going to spend time on this. Now, conditional probability is also very easy to understand. It simply tries to determine the probability of an event given a previous event. We'll use an example to explain this. So if we talk about the 3 red balls and 2 blue balls in a bag, you can think of taking out a red ball for the first time, and the second time you are taking out another ball. So what's the probability in the second case? That is what we call conditional probability. Probability given a prior event that has happened. So before we go into the notations, let's take an example, because examples makes it very clear. In this case, a medical diagnosis is carried out on patients with heart disease called digital intoxication or digitalis intoxication. To carry out this diagnosis, doctors measure the concentration of digitalis in the patient's blood. Because this diagnosis is difficult, they have to perform a measurement and they'll be able to determine if this patient has this heart disease. Now, when they carry out this measurement of the concentration of digitalis in the person's blood, high concentration, they can conclude that the patient have this disease of the digitalis intoxication. So let's now look at the table here. 136 patients were diagnosed and tabulated below. Now let's use the notation that T plus means high concentration of this substance. T minus means low concentration. D plus means disease is present, and D minus means the disease is absent. So what the doctors do is, when the concentration is high, they now determine or they assume that the disease is there. Because when the concentration is high, it means that there is high likelihood that the disease is there. But that does not always mean the disease is there. It's just a diagnosis method that if the concentration is high, then let's just assume the disease is there. Let's understand what is happening in this table. Now, in the first case, we have D plus D minus, T plus T minus. The first figure 25 under D plus and T minus shows that 25 patients out of the 136 has high concentration of this substance and also has the disease, right? So this means that this is 0.184. So let's get it clear. So 25 out of 136 has a high concentration and also has a disease. This is probability of 0.184. We are going to explain it a little bit more, but just understand the table. This 15 means that 15% has high concentration of this substance but does not have the disease. So it means that if this 15% that have high concentration actually does not have the disease, but to the doctors will conclude that they have the disease because by their measurement it shows high concentration. And this 18 says that 18 out of the 136 patients have the disease, but they don't have high concentration of this chemical substance. And they'll have 78% of the patients, they said, have low concentration of this substance and they don't have the disease. Now, before we continue, let's convert this table to frequencies so that we can apply it to larger population. We simply divide everything by 136 and the result is tabulated below. 25 over 136, 15 over 136, 18 over 136, and so on. And then we have table of frequencies below. Now let's go to the interesting part of it, the probability aspect of it. Now I'm going to take a pen and then so that we can write to see what is happening here. Now we have, sorry, let me make some room by shifting this a little away from here. Okay. So, so let's give it a second. So let's see. So we have that probability of T plus, probability of T plus, probability of T plus. So this is the probability that a patient has the disease. Is actual total probability that the patients have the disease because they have high concentration of the chemical in their blood, of the substance in their blood. So the probability that they have high concentration is actually 0.294 because we sum the two probabilities or these two values and it gives us 0.294. So the summation of whatever is in the row of T plus gives us the probability of T plus. So in this population of 136 people, the probability that a patient has a high concentration of the substance is 0.294. So let's see the clear explanation and let's write the next one. Probability of D plus is equal to, this is 0.294. Probability of D plus is whatever we have here, which is 0.316. Now we can ask, if a doctor knows that there is high concentration, that is the test was a positive test, T plus, what is the probability of the disease being present? That is now conditional probability. So what we are saying here is, when the doctor carries out the test and finds out that there is high concentration of this substance in the patient's blood, what is the probability of the disease being present? This is where conditional probability comes into play. Looking only at the first row, we can see that out of 40 patients who show high concentration, 25 of them have the disease. Let's go back to this place. So out of 40 patients that has high concentration of this substance, 25 of them have the disease, right? Good. So let's denote the probability that a patient has the disease given that the test is positive by P, D plus, T plus. Now this is the first notation you need to understand about conditional probability. So when you have probability and you have D plus, T plus. So this reads the conditional probability of D plus given T plus. The conditional probability that the patient have the disease given that there is high concentration of the substance, or the probability that the patient have the disease given a positive test result. In this case, probability of D plus C plus is equal to 25/40, which is equal to 0.625. From the table, we have probability of D plus given T plus, probability of D plus given T plus, which is at this point, which probability of D plus given T plus is 0.294, probability of D plus given D plus alone is 0.316. This time, how do we now find probability of D plus given T plus? That is where we now use the formula that I wrote in the beginning of this page. So we have this formula here, and I'm going to write it out, and then we are going to try to understand it and see how we can apply it. So probability of A given B is equal to probability of A intersection B. Remember, we mentioned the set theory, all over probability of B. So this is conditional probability of A given B. This is probability of B, and this is probability of A intersection B, A and B together. So let's get back to where we stopped. So we are trying to find conditional probability of A given B. In this case, the conditional probability of D plus given C plus. So using the formula that we have here, we can just write it as, it's the same as probability of D plus, right? Because following from this place, probability of the disease is there given T plus. So it's the probability of D plus. Sorry, I'm making a mistake here. Alright, so let's continue. So I want you to pay attention to what I'm writing because this is very important. So probability of D plus given T plus, I'm making the same mistake. Probability of D plus intersection T plus all over the probability of T plus. So in this case, D plus intersection T plus, we can directly find it from the table. So D plus intersection T plus, as you can see, is 0.184. So we have, this is going to give us equals 0.184 all over probability of T plus is the total probability of T plus, not the conditional probability this time. So at this point we have 0.294 is probability of T plus, not conditional probability. And we can just go ahead to write it to be 0.294. So if we do this, we have 0.625. So this is the same thing we calculated in this place when we have 25/40, but this time we use the conditional probability formula to actually do it. So I hope this is a bit clear. If not, try to run through it again to become a bit clearer as you move. This is what conditional probability is all about. So now we can think of it as, we can think also of unconditional probability. I'll allow you some time to digest what we've just discussed about conditional probability. Now, in the next part, we are now going to compare it with unconditional probability. Is there anything like that? And then how can we use it to get a clear understanding of what we are learning? I'd like to remind you to subscribe, and also I'd like to thank you for viewing.